Let's check the duplicate of this dataset. We'll be using dataframe.duplicated to see if any. You can simply put this in a square bracket inside a df with df.duplicated and check the length of it. You can see that currently we're getting 0, which is perfect, which means there are no duplicates in our dataset. Let's see some summary statistic. For that, we'll be using a .describe function. Once you do df.describe, you will get to see a table like this. Do remember, this will only run for all numerical values. In this table, you will notice it will give you a count, which is the total count of this particular column. Total count as in total values that we have in this column. It will give you the mean of those, standard deviation, minimum, 25, 50, and 75 percentile of the data, and the max value. As you would have noticed that it's too messy to deal with our data as is. What we are going to do is we're going to create a subset of it. We will limit the data to customer ID, product title, product parent, star rating, helpful votes, and total votes. To do that, you can simply do double square bracket access of pandas data frame and then create a subset and name it as df_reduce. Let's see the data, and you should be able to just do dot head of df_reduced, and you will be able to see all the columns that we have subsetted. Now we can also quickly check the summary statistic of this dataset like we did for the normal df as well. This will again give you the same data, which is count, min, standard deviation, min, different percentiles, and max. But this time you do have different columns compared to the previous one. Again, do remember, by default, it will only give you numerical columns. Looks like dealing with this wide range of data using numbers is not suitable. Visualization is a must right now, but before moving on to that, let's check whether we have duplicate again in the df.reduce. We'll use the same function, but this time we'll pass df_reduce and check the len. What you can see here is rather than getting 0 like we did for df, we are getting 85, which means that you do have 85 values which are duplicate. The next step for us is we'll try to find out for each column how many unique values exist. For that, we can simply use .unique and run through a for loop. In this, we are accessing each columns in df_reduced and then simply printing column and the unique values by taking the df_reduce columns .unique, multiplying that by 100 and dividing that by len of df_reduced. We're also taking round so that we get 3 digits after the decimals. As you can see that some of the columns have, for example, customer ID has 50.476% unique values. Column star rating has 0.0% unique values. And similarly, total vote has 0.011% unique values. We can deduce a lot from above cell. For example, first is every customer ID appears to be almost twice in the dataset, and this is somewhat justifiable. We have small number of products. This is obvious when looking into the product ID column. There's no variation in all star rating column, which means it won't be used in our prediction. Let's try to reflect some of the duplicates of the last dataset in df. Again, we got to know this when we reduced the df to df_reduce by removing certain columns. If you now do a specific customer ID and customer product, you will see 2 rows corresponding to 2 different review IDs. However, all the values are very similar. In fact, except review ID, everything else is exactly same. This is why we were able to get 85 duplicate values in the reduce dataset. In this video, we will try to explore our dataset using some visualization. For this purpose, we will use Seaborn library with basic pandas data manipulations. First, let's count the number of star rating using value count function, and then we will plot this using sns.barplot. For plot, our x is the index of new data frame we created in the first step, and y is the star count. You can see from the graph that we have very high frequency of 5 rating and rating 2 being the least. Now let's explore month-specific review count. To achieve that, we have to first group by our data using pandas group by function. We start by doing df.groupby, which will group all the data month-wise. Do remember that our data doesn't have month values directly, but we can get them from date by doing .dt.month on review date column. Once we have group of month, we can simply access star rating and count them. You can see the table summarized based on months and their respective counts. We can now simply plot this using SNS bar plot. This shows us that month 8 has the highest rating and month 9 has the lowest. Now we do the same steps for year-wise analysis. Just a small change, which is dt.year on review data, and we can see the chart year-wise. You can see from the chart that it's quite obvious that year 2014 and 15 has higher counts of reviews, whereas 2000 till 2010 we have a very little count. Now let's address how heterogeneous are the number of reviews per customer and reviews per videos we have. To do that, we will use quantile methods to find out. To start, we will first create two different data frames, customers and products, with their value counts. Then we define different quantiles that correspond to specific level of ratings. We then simply print the customers and the product count percentile using the values defined in the previous step. You can see the print of values using this. We can conclude from the above values that only about 5% of the customers have rated 5 or more videos, and only about 25% of videos have been rated by 9 plus customers. We will now filter out this long tail and select the customers that have rated 18 or more videos and the products that have more than 95 reviews. Let's see the length of newly created data frame. In this, you can see that the number of user is 10,538 and the number of item is roughly around 6,600. The length of reduced DF is 173,000. You can also quickly see the head of the reduced DF. Now let's also check if reduced DF maintain the same distribution of star rating as original DF. To do that, we can simply use the same code we used initially to get bar plot of DF and run it on reduced DF. The number of reviews with 1-star rating decreased in proportion to 2-star ratings. That was not the case with the original data. Now let's recreate the customer and product distribution of count per customer and product, but this time with reduced DF. To do that, we can simply create two different data frames like we did previously from DF, which is customers and product, but this time using reduced DF. Once these DF are built, we can simply use Seaborn subplot to create two different plots and then add dist plot, which is distribution plot, to display the distribution counts per customer and product. Finally, as a last step, we can merge both the data frames together using Panda's merge function and check the final results. To prepare for training, our first focus is pre-processing, and we can do this by using various tools, that is AWS Services, AWS Glue, Amazon EMR, Amazon Redshift, Amazon Relational Database Services, and Amazon Athena. After pre-processing, we can publish the data to Amazon S3 bucket. For the purpose of training, the data needs to go through a series of conversion and transformations, including training data serialization, which should be handled by you, training data deserialization, handled by the algorithm, training model serialization, handled by the algorithm, and finally train data deserializations, which should be handled by you. In the training part of the algorithm, make sure to upload all data at once when using Amazon SageMaker. If additional data is added to the location, a new training call would need to be made to construct a brand new model. Let's discuss some of the training formats we have in SageMaker. The first one is CSV. Amazon SageMaker algorithm supports training data in CSV format. In the input data channel, content type as text or CSV can be defined in such cases. Amazon SageMaker requires target column as the first column for any supervised learning algorithms. If we encounter with non-labeled data and decide to run unsupervised learning algorithm, we need to specify the number of label columns in the content type. For example, the content type could be text CSV and the label size could be 0. The next is record IO format. Amazon SageMaker algorithm works best when optimized proto-buff record IO data format for training is being used. By using this format allows you to take advantage of pipe mode. In pipe mode, your training job streams the data directly from Amazon's simple storage service, which we refer to as Amazon S3. The streaming data can provide faster start time for training jobs and better throughput. This is in contrast to file mode, in which your data from Amazon S3 is stored on the training instance volume. File mode uses disk space to store final model artifact and training dataset. By streaming data directly from Amazon S3 in pipe mode, we can reduce the size of Amazon Elastic Block Store volumes of training instances. Pipe mode needs little disk space to store final model artifact. Now let's discuss about trained model deserialization. Amazon SageMaker models are stored as model.tar.gz in the S3 bucket specified in output data config S3 output path parameter of the create training job call. You can specify most of these model artifacts when creating a hosting model. You can also open and review them in your notebook instance. When model.tar.gz is untarred, it contains modelalgo1, which is a serialized Apache MXNet object. For example, you can use the following to load the k-means model into memory to view it. Now we are at a point where you can start preparing the dataset as input for your model. Every model has a different input needs. Some of the algorithms implemented in Amazon SageMaker requires the data to be at the record IO wrapped proto buffer form. You will take care of that in the following cell. First, split the dataset into training and test set. This will allow you to estimate the model's accuracy on video that customers rated but weren't included in the training. We start by creation of the test data frame. To do that, we can simply create a data frame by grouping the data frame on customer ID and using the last function similar to pd.groupby.last. To create the training data, remove the values present in the test data from the reduced DF data frame. By doing the merge, the reduced DF data frame with the test DF dataset with customer ID and product ID columns as an outer join. You can see the head of the trained DF after doing this operation. Let's create two variables NB training test and NB training train for the length of the test and the training dataset. Now you can simply convert your pandas data frame into a sparse matrix. This process is same for both train and test. Therefore, you're going to convert the data to a sparse matrix to express the relationship between each user and each movie. To do that, we'll start defining a function load dataset, which takes data frame lines, columns, and regression as a parameter, where df is a data frame, lines are number of rows of the final sparse matrix, columns are number of columns of final sparse matrix, and regressor is Boolean value to check if you are using regression or classification. We will also make sure to import this little matrix, which is required for us in the next step. The return of this function will be x and y, x being the feature vector and y being the label vector. Now to create the x, which is a feature vector, we will use scipy.sparse.lilmatrix function to create a feature vector x of type float32. This will help us create one hot encoded feature in a sparse matrix. We will also initialize empty list to store the labels as y. Now we start writing a for loop where it should go to each row and start creating a sparse representation from the product to customer mapping. Once we are done with the function, we can simply call the function and pass our train and test data. This will give us features for train and test along with their respective labels for both train and test data, which you can see here, which is xtrain, ytrain when we pass the train df and xtest and ytest while passing the test df. Now that our data is in sparse format, we will try to save it as a protobuf format and upload it to Amazon S3 bucket. This step might look intimidating, but most of the conversion effort is handled by Amazon S3 SageMaker Python SDK, imported as SageMaker below. To start, we simply create a bucket in S3 by using Amazon Python SDK and using S3 API function, which creates a bucket parameter. To start, we simply create a bucket in S3 by using Amazon Python SDK and using S3 API function with create-bucket parameter. We also pass name of the bucket next to -- bucket and a region which is US West 2. You can change this to your own region if need be. Then we enable dash dash create dash bucket dash configuration along with location constraint. Now in this case, you can see that there is an error which basically points out that your previous request to create name bucket succeeded and you already own it, which simply means that the bucket that you're trying to create already exists. But once you run it for the first time, you will get something like that you now have a bucket and we are calling this as Amazon Review Skillsoft. Now that we have a bucket, let's write a function that writes and uploads our data. To do that, we first import IO and smack from SageMaker Amazon.com. Smack has the function that we are interested in, which is write SP matrix. We start by defining the function, which is write dataset to protobuf, which takes the object as ACK. We start by defining the function write dataset to protobuf, which takes the object as X, the bucket details as bucket, prefix keys and data types. It also has an optional parameter to take Y or a class label. Inside a function, we start by defining byte IO object buffer. Then we simply check if the input that has been sent to is in sparse format already or not. If it is in sparse format, we simply call smack.write SPA matrix to sparse tensor function and pass the buffer and our features and vectors. If we have parsed data, then we simply use a different function, which is smack.write numpy to dense tensor. Once the transformation of matrix to buffer has been achieved, we simply use boto3 and the function upload file object to upload our buffer to S3 bucket, which we created in the first step. Alright, so now we have a function defined. Let's go ahead and implement it by sending our train and test data. We simply define a bucket name and prefix, which is required parameter of our function. We then call the function for both train and test. Once we call, we can simply print the values of S3 bucket, path stored and variable. You can see it that it tells us where the values has been in the S3 bucket and it tells you the exact path of where the files are. Let's talk about SageMaker Ground Truth Services. This is a relatively new product from Amazon. It's basically a way of using humans to label your data. So for example, if I'm training a new image classification model, in order to train that, someone has to go through and actually tag all these training images with what's actually in them. So Ground Truth will manage a fleet of human beings who will go through and label your data for training purposes. So if you have a huge data set like a bunch of pictures and you need labels on them, sometimes human beings are the best way to actually get those labels. Ground Truth is what manages that process for you. But it's more than just managing the human that label your data. The thing that sets Ground Truth apart is that it creates its own model as those labels are coming in. So this model is learning as it receives more and more label data from the humans, and over time it's only going to send out labels to humans that it is not sure about. So as time goes on, as it gets more and more labels from the human labelers, it will create a model of its own and only the ambiguous cases will be sent out to humans for confirmation. So this model builds up over time and gets better and better in a given time. This ends up reducing the cost of your labeling jobs by up to 70%, which is very substantial. Now let's understand who are these people. Ground Truth can use the Amazon Mechanical Turk workforce. This is a huge workforce of people around the world who will label your data and do a bunch of other simple tasks for you for a very small amount of money. You can also choose to hand it to your own internal team if you're dealing with very sensitive data. Also, there are professional labeling companies out there as well who do nothing but have a fleet of human beings who label training data for a living. If you want someone who's little bit more specialized in this sort of training, you can spend even more money and use one of them. Now there are other techniques and just using humans to actually generate training labels that you don't have. One other would be to use AWS Recognition Service. Basically, it's an AWS service for image recognition. So if you do not need to classify images, that could be there for creating labels or maybe even feature data, or maybe just to have a feature in your dataset for what is in the image. Recognition has a pre-trained model for most common types of objects that you can just use. So if you're just using classification of general objects in the world, Recognition might be able to do that for you. In this section, we will discuss on SageMaker. Just an information, AWS exam mostly focuses on security and it has a great value in terms of importance. Going forward, we will discuss on general best practices with AWS security, which applies to SageMaker along with Amazon's machine learning services. Let's talk about identity and access management services. IAM or Identity and Access Management Services is useful to restrict the permission of all different services which are talking to each other within the system of organization. IAM also can be used to set up user accounts for AWS and also give permissions to authenticate accounts. If you've decided to run SageMaker Notebook, then restrictions on permissions can be given for setting up SageMaker Notebooks, and also IAM can be used to access the data by using S3 bucket. Next is multi-factor authentication. Multi-factor authentication has its own benefit to make sure that the access is given to a verified user, where both type of accounts, that is administrator account and a route account, shall have proper restrictions which is designed by the organization. Now let's discuss about security best practices. The first one is use SSL or Secure Socket Layer and TLS, which is Transport Security Layer, as and when required to connect with servers and users. EMR, which is known as Elastic Map Reduce, this is also a very important component in the machine learning world while using cloud services. In EMR, you can have a various instance stored and directly accessible from server. Best practice says that use SSL when connecting to the servers directly so that security is completely established while accessing the servers. Next is Amazon CloudTrail service. Amazon CloudTrail service can be used to log activities for the APIs which has been used by the user or developed by the user. The advantage here is a complete audit trail will be displayed on the application page, where summarized information of used API shall be displayed across the server on the working project. Amazon CloudTrail is being used for auditing of the user activity. There is another term called CloudWatch, which is being used to monitor log data and issue alarms when something is incorrect. And the last one is to use encryption whenever appropriate. It's always good to use encryption with PII, personally identifiable information. If organization is dealing with sensitive data like names, emails, house address, or social security number, or even credit card numbers, etc., we have to make sure those are encrypted end to end. Now let's see Amazon Key Management System and let's dive into more detail on how to encrypt data by using SageMaker. In Amazon SageMaker, to encrypt data, Amazon Key Management Services can be used. In any SageMaker jobs, we deal with notebooks and various types of important data which is supposed to be encrypted. That encryption can be taken care by using KMS keys, where it can help to encrypt entire data such as artifacts coming from training, parameter tuning, batch transformations, and different endpoints. This sensitive data is being stored in SageMaker platform, and this is where encryption plays a major role, and KMS helps to manage this data by providing keys to the user for encryption. Along with above, there's also a problem of securing training data and the data used for hosting our model. This is where we can use standard S3 encryption technique. S3 supports various kind of encryption at rest, and in the transit example, you can encrypt S3 buckets for your training data and for hosting your trained models. S3 can use KMS services, but that's optional and can generate its own key for encryption. Now let's look into certain security best practices. The first one is during transition process, all traffic supports TLS and SSL inside the SageMaker. IAM, Identity and Access Management, can also be used to grant permission for specific resource access in SageMaker. IAM can also help to follow the principle of least access. Least access is nothing but a limited permission to the user identity within a SageMaker itself for accessing the data. This is to say, access can be given to specific user, and based on absolute need and rest, access can be rejected. And now at last, we can optionally encrypt the inter-node training communication as well. This is to say, if training is happening on multiple nodes, those nodes and training can be encrypted too. Now let's look into a basic security concern. We might raise a question on above and argue
What if someone actually intercepts traffic? An organization needs to meet the regulatory requirement which is supposed to be encrypted. If organization is dealing with sensitive information, and imagine if we are running complicated deep learning algorithms which is spread across multiple nodes and time consumption is very high. Hence we can say that it's a costly affair on SageMaker, but that needs to be dealt properly with real cost without thinking twice. We can also call this inter-container traffic encryption. It can be turned on via the console when you're setting up your training job or using API for training.
There are some specific concerns around VPC with SageMaker that you need to know. So when you're running a training job in SageMaker, that's running within a virtual private cloud or VPC. Now, if you really need extra security, you could even use private VPC for that. You can specify that when you're launching your training job. However, that creates some problem because SageMaker depends on having access to S3 to get its training data and also to get the train model artifact for when it's actually deploying your model. So we need to make sure that at least we have connectivity between SageMaker and S3 within a private VPC. That means you'll have to set up S3 and VPC endpoint to enable communication, and you can still use custom endpoint policies and bucket policies within S3 to keep that secure. But you do need to set that up in SageMaker also. Another consideration with security in SageMaker is that SageMaker notebooks are internet enabled by default, which means your notebook can go out on the internet and download data and do whatever it wants to. But this is kind of a security hole, so you can disable that while you're creating your SageMaker notebook. Do remember, if you disable internet, you would still need to get out to S3 somehow in order for SageMaker to work. So if you do disable internet access on your notebook, you're going to have to set up an interface endpoint that's also known as private link, or maybe a NAT gateway, and set up outbound connection to actually allow your training and hosting to work. Also, your training and inference containers are also internet enabled by default. It is possible to enable network isolation on those as well, but again, you're going to lose S3 access by doing so. So you'll have to work around on that somehow, and it's a security concern in general that SageMaker has to access S3. We also mentioned IAM with SageMaker, the Identity and Access Management Service. Here is a list of some of the specific permissions you can set that are related to SageMaker. You can set specific permissions like creating training jobs, creating models, creating endpoints, creating hyperparameter tuning jobs, and creating notebooks. You can lock these down or enable them to whatever degree makes sense for a given user. So if I want a user that I just want to be able to create notebook but not actually deploy them, or create notebook but not actually create a huge training job that might cost a lot of money, or I might just want to lock down hyperparameter tuning jobs because those in particular can get really expensive. You can do all of these through permissions with IAM and SageMaker. There are also some predefined policies you can use, such as SageMaker read-only access, SageMaker full access, administrator access, and data science policies as well.
In this video, we'll talk about Amazon CloudWatch. Amazon CloudWatch is a monitoring and observability service built for DevOps engineers, developers, site reliability engineers, and IT managers. CloudWatch provides you with data and actionable insights to monitor your application, respond to system-wide performance changes, optimize resource utilization, and get a unified view of operational health. CloudWatch collects monitoring and operational data in the form of logs, metrics, and events, providing you with unified view of AWS resources, applications, and services that run on AWS and on-premise servers. You can use CloudWatch to detect anomalous behavior in your environments. You can set alarms, visualize logs and metrics side by side. You can set to take automated actions, troubleshoot issues, and discover insights to keep your application running smoothly. Let's see how Amazon CloudWatch works. CloudWatch collects monitoring and operational data in the form of logs, metrics, and events and visualizes it by using automated dashboard so that unified view of AWS resources, application, and services can be visualized, which is running in AWS. You can create a relationship between metrics and logs for the better understanding where health and performance of the resources can be checked. Based on metric threshold value, we can set up alarms. Anomalous metric behavior of machine learning algorithms can also be watched. For the quick action, you can set up automated actions, which can be notified if alarm is triggered and automatically start auto-scaling. You can also deep dive and analyze metrics, logs, and traces for better understanding and improve your application performance as and when required. Now let's look into Amazon CloudWatch advantages. The first one is infrastructure monitoring and troubleshooting. It helps you monitor key metrics and logs, visualize your application and infrastructure stack, create alarms, and correlate metrics and logs to understand and resolve root causes of performance issues in AWS resources. This includes monitoring your container ecosystem across Amazon ECS, AWS Fargate, Amazon EKS, and Kubernetes. The next is log analytics. Explore, analyze, and visualize logs to address operational issues and improve application performance. To quickly and effectively respond to operational issues, you can perform queries. If an issue occurs, you can start querying immediately by building a language query for potential causes. Next is application monitoring. Monitor application which executes on AWS, on Amazon EC2, containers, and serverless, or on-premise. CloudWatch collects data at every layer, including metrics and logs and automated dashboards. The last is mean time to resolution improvement. CloudWatch helps you correlate, visualize, and analyze metrics and logs so that issue can be resolved quickly. Combine them with trace data from AWS X-Ray for end-to-end observability. You can also analyze user requests to help speed up troubleshooting and debugging, and reduce overall mean time to resolution, referred to as MTTR. AWS CloudTrail is a service that enables governance, compliance, operational auditing, and risk auditing of AWS account. With CloudTrail, you can log, continuously monitor, and retain account activity related to actions across your AWS infrastructure. Let's look into more details of Amazon CloudTrail. CloudTrail provides event history of your AWS account activity, including actions taken through the AWS Management Console, AWS SDK, command line tools, and other AWS services. This event history simplifies security analysis, resource change tracking, and troubleshooting. In addition, you can use CloudTrail to detect unusual activity in your AWS accounts. These capabilities help simplify operational analysis and troubleshooting. Now let's look into Amazon CloudTrail advantages. The first one is simplified compliance. With AWS CloudTrail, simplify your compliance audits by automatically recording and storing event logs for actions made within your AWS account. Integration with Amazon CloudWatch logs provide a convenient way to search through log data, identify out-of-compliance events, accelerate incident investigation, and expedite responses to auditor requests. Security analysis and troubleshooting. With AWS CloudTrail, you can discover and troubleshoot security and operational issues by capturing a comprehensive history of changes that occurred in your AWS account within a specified period of time. Next is visibility into user and resource activity. AWS CloudTrail increases visibility into your user and resource activity by recording AWS Management Console actions and API calls. You can identify which users an account called AWS, the source IP address from which the calls were made, and when the calls occurred. The last is security automation. AWS CloudTrail allows you to track and automatically respond to account activity threatening the security of your AWS resources. With Amazon CloudWatch events integration, you can define workflows that execute when events that can result in security issues when they are detected. For example, you can create a workflow to add a specific policy to an Amazon S3 bucket when CloudTrail logs an API call that makes that bucket public. Let's summarize what we have covered so far in this course. We've seen summary statistics and visualization. We've seen Amazon SageMaker practice tutorial. We've also seen Amazon SageMaker security best practices. And we have seen Amazon CloudWatch and Amazon CloudTrail. Coming up next is model training and evaluation.